All right, everyone, welcome to part 6 of me learning Rust series. This is Vern Connor. So comments, let's see. We strive to make our code easy to understand, but sometimes extra explanation is warranted. Leave comments in their source code. Okay, so double /, that's a line comment. Idiomatic comment style starts a comment with 2 slashes. The comment continues until the end of the line. For comments that extend beyond a single line, you'll need to include really. Okay, so no multi-line comment syntax at the end of lines. Okay, but you'll more often see them used in this format with the comment on a separate line, like this. Rust also has another kind of comment, documentation comments, which we'll discuss in publishing a crate to crates.io. All right, let's continue on. Comments, now control flow. The ability to run some code depending on whether a condition is true and to run some code repeatedly while the condition is true are basic building blocks in most programming languages. The most common constructs that let you control the flow of execution of Rust code are if expressions and loops. If expressions. An if expression allows you to branch your code depending on conditions. You provide a condition and then state, if this condition is met, run this block of code. If the condition is not met, do not run this block of code. Create a new project called branches in your projects directory to explore the if expression in the source main.rs. Okay, so let's do cargo new branches. All right, cd branches, let's get in there and let's go to branches, source main. All right, so let's write down that code. Let number, assignment 3, if number smaller than 5, print line, condition was true. Okay, and then else, and then the else block, print line, condition was false. Okay, let's do cargo run. Condition was true. There we go. 3 is smaller than 5. All right. All if expressions start with the keyword if, followed by a condition. In this case, the condition checks whether or not the variable number has a value less than 5. Number less than 5, that's the condition. We place the block of code to execute if the condition is true immediately after the condition inside curly brackets. So this will execute if the condition is true. Blocks of code associated with the conditions in if expressions are sometimes called arms, just like the arms in match expressions that we discussed in chapter 2. Optionally, we can also include an else expression, which we chose to do here to give the program an alternative block of code to execute, should the condition evaluate to false. So if this condition returns false, this block is going to be executed. If you don't provide an else expression and the condition is false, the program will just skip the if block and move on to the next bit of code. I ran the code. Let's try changing the value of number to a value that makes the condition false. So let's make that a 7 and then run it again. Condition was false because 7 is not smaller than 5. So this expression becomes false. It's also worth noting that the condition in this code must be a Boolean. If the condition isn't a bool, we'll get an error. For example, try running the following code. If number. Okay. You can actually do something like this in one of the C languages. I think C itself, maybe. The if condition evaluates to a value of 3 this time, and Rust throws an error because 3 is not bool, right? Numbers, this is an int. Expected bool found integer. This error indicates that Rust expected a bool but got an integer. Unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert non-Boolean types to a Boolean. Good for Rust. You must be explicit and always provide if with a Boolean as its condition. If we want the if code block to run only when a number is not equal to 0, for example, we can change the if expression to the following. If number is not 0, not equal 0. Very good. If number not equal 0, then return true. Condition was true. Number was something other than 0. Okay, let's paste that in as well. Just the if block. And run it. Number was something other than 0. Handling multiple conditions with else if. You can use multiple conditions by combining if and else in an else if expression, for example, that. All right. Let's type it. Let number 6, if number remainder 4, remainder from division by 4 is equal to 0, number is divisible by 4. Is divisible by 4. Okay, there we go. Else if, again, number remainder from division by 3 is equal to 0. Then the number is divisible by 3, obviously. Else if number, the remainder of number divided by 2 is equal to 0, then number is divisible by 2. If all of these fail, then the number is not divisible by these numbers, right? Is not divisible by 4, 3, or 2. There we go. This program has 4 possible paths it can take. After running it, you should see the following output. Let's run it. Cargo run, divisible by 3. Wonderful. When this program executes, it checks if expression in turn, each if expression in turn, and executes the first body for which the condition evaluates to true. Right, so it checks this condition. This is false, right? 6 divided by 4 has a remainder of 2. So this is false. Then it checks if, else means if this is false, right? Check this. So number divided by 3 has a remainder of 0. So this block is executed. And that's it. The flow exits the if, else block entirely after executing this. Okay, that's because Rust only executes the block for its first true condition, and once it finds one, it doesn't even check the rest. Yep. Note that even though 6 is divisible by 2, we don't see the output number is divisible by 2, nor do we see numbers not divisible by 4, 3, or 2. text from the else block. That's because Rust only executes the block for the first true condition. So once the program flow finds true in one of these conditions, the block that belongs to that true condition is executed, and then the entire if-else block is exited. Using too many else-if expressions can clutter your code, so if you have more than one, you might want to refactor your code. Chapter 6 describes a powerful Rust branching construct called match for these cases. Okay. Using if in a let statement. Because if is an expression, we can use it on the right side of a let statement to assign the outcome of a to a variable. It's in listing 3-2. Assigning the result of an if expression to a variable. Okay. What does it return? Interesting. This thing returns something. If condition 5, else 6. Oh, if condition is true, then return 5. Otherwise, return 6. This entire thing is going to return something, 5 or 6, based on the condition being true or false. All right. I gotcha. The number variable will be bound to a value based on the outcome of the if expression. Let's do that. Let condition true. Let number, if condition, value is true, return 5. Otherwise, return 6. And then print the line. The value of number is number. Cargo run. The value of number is 5. Okay. Because condition is true. If it were false, then the value would be 6. There we go. The number variable will be bound to a value based on the outcome of the if expression. Run this code to see what happens. Remember that blocks of code evaluate to the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. This means the values that have the potential to be results from each arm of the if must be the same type. Really? Wait. Okay, values that have the potential to be results from must be in listing 3-2. The results of both the if arm and the else arm were i32 integers. If the types are mismatched, the following, as in the following example, will get an error. Interesting. When we try to compile this code, we'll get an error. The if and else arms have value types that are incompatible. And Rust indicates exactly where to find the problem in the program. Why? Expected because of this. Interesting. So this entire... The expression in the if block evaluates to an integer, and the expression in the else block evaluates to a string. This won't work because variables must have a single type, and Rust needs to know at compile time what type the number variable is definitively. Knowing the type of number. Oh, I see. So Rust kills any ambiguity here as well. And you can define, while declaring the variable, you can declare its type as well. So it needs to have a single type, and this expression needs to... So there is no conditional type declaration, I guess, by having a conditionals here with different types returning value. Okay. Rust wouldn't be able to do that if the type of number was only determined at runtime. The compiler would be more complex and would make fewer guarantees about the code if it had to keep track of multiple hypothetical types for any variable. Okay, so this is a trade-off for safer code, basically, that Rust authors basically made. Repetition with loops. It's often useful to execute a block of code more than once. For this task, Rust provides several loops, which will run through the code inside the loop body to the end and then start immediately back at the beginning. To experiment with loops, let's make a new project called loops. All right, let's do that. Cargo new loops. And then open it up here. Loops. All right, this looks like an infinite loop. Loop block. And I'll get the print line here. Again. When we run this program, let's run that. Cargo run. We get an infinite loop. Yeah. Control C to interrupt. There we go. Represents where you press Control C. I don't have that here. You may or may not see the word again printed after that C, depending on where the code was in the loop. Fortunately, Rust also provides a way to break out of a loop using code. You can place the break keyword within the loop to tell the program when to stop executing the loop. We did that in chapter 2. Okay. We also used continue. So break is one keyword to break out of the loop completely, and continue is to break out of the current iteration to continue on to the next one. Returning values from loops. One of the uses of a loop is to retry an operation you know might fail, such as checking whether a thread has completed its job. You might also need to pass the result of that operation out of the loop to the rest of your code. To do this, you can add the value you want returned after the break expression you use to stop the loop. That value will be returned out of the loop, so you can use it. What is that? Break counter. Oh. So you can do break and then return something. Cool. And the result is result. Oh, here. And this is a loop, I guess. I'm breaking out. If there's a value here, it is returned. You do have a semicolon here, though, at the end, even though this returns a value. It's a statement. It's a value returning statement, I think. Anyway. Before the loop, we declare a variable named counter and initialize it to 0. Okay. Then we declare a variable named result to hold the value returned from the loop. All right. On every iteration of the loop, we add a 1 to the counter variable right there. And then check whether the counter is equal to 10. If counter is equal to 10, you break out of the loop. When it is, we use the break keyword with the value counter times 2. After the loop, we use a semicolon to end the statement that assigns the value to result. Finally, we print the value in result, which in this case is 20. Cool. Let's try that. Cargo run. Result is 20. Nice. This is very, very interesting. You have a loop here and an assignment after the loop. Cool. Loop labels disambiguate between multiple loops. If you have loops within loops, break and continue apply to the innermost loop at that point. you can optionally specify a loop label on a loop that you can then use with a break, or continue to specify that those keywords apply to the label loop instead of the innermost loop. Loop labels must begin with a single code. Here's an example with 2 nested loops. Okay, let mute count 0. Okay, a loop label, I guess, and then the loop itself. Let mute remaining 10. And then another loop here, an inner loop. If remaining is equal to 9, break. If count is equal to 2, break out of the outer loop. Remaining, you decrease by 1 at each iteration of the inner loop. And count, you increase by 1 with each iteration of the outer loop. Print line and count. Okay, let me copy this. See what it produces. Cargo run. Count 0, remaining 10, 9. Alright, when it gets to 9, it just breaks out of the inner loop. Count increases by 1 in the outer loop, and then 10, 9 again in the inner loop. Count increases by 1, 10, 9, 10 again. There's no 9, because after 10, since count was 2, this code was executed, and this was never executed in the last iteration. Cool. The outer loop has a label counting up, and it will count up from 0 to 2. The inner loop without a label counts down from 10 to 9. The first break doesn't specify a label. Will exit the inner loop only. Yeah, so this one will exit the inner loop. The break counting up statement will exit the outer loop, that one. This code prints that, yep, conditional loops with while. So loop just loops. It's like while true, I guess. A program will often need to evaluate a condition within a loop. While the condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. It's possible to implement behavior like this using a combination of loop, if, else, and break. You could try that now in a program if you'd like. However, this pattern is so common that Rust has a built-in language construct for it called a while loop. In listing 3-3, we use a while loop. We use while to loop the program 3 times, counting down each time, and then after the loop, print a message and exit. So while condition. While this condition is true, you continue looping. This is like the while loop in other languages, I think. Let's see what happens here. 3, 2, 1, lift off. Nice. So while number is not 0, you print the number, and then you decrease the number by 1. Simple. Okay, cool. And then when it gets to 0, this loop ends, of course. This construct eliminates a lot of nesting that would be necessary if you use loop, if, else, and break, and it's clearer. While a condition evaluates to true, the code runs, otherwise it exits the loop. Looping through a collection with for. You can choose to use the while construct to loop over the elements of a collection, such as an array. For example, the loop in listing 3-4 prints each element in the array A. Let's see. There is an array here with these numbers. Index 0. While index is smaller than 5, print A index. And then increase the index by 1. Alright, so this is one way to run through an array, I guess, with while. I think for each loop, or a for loop like it's implemented in Python, would be better. Here the code runs up through the elements in the array. It starts at index 0 and then loops until it reaches the final index in the array. That is when index smaller than 5 is no longer true. Running this code will print every element in the array. All 5 array values appear in the terminal as expected. Even though index will reach a value of 5 at some point, the loop stops executing before trying to fetch a 6 value from the array. However, this approach is error-prone. We could cause the program to panic if the index value or test condition is incorrect. For example, if you change the definition of the A array to have 4 elements but forgot to update the condition while index smaller than 4, this magic number here, the code would panic. It's also slow because the compiler adds runtime code to perform the conditional check of whether the index is within the bounds of the array on every iteration of the loop. So it's slower. As a more concise alternative, you can use a for loop and execute some code for each item in a collection. A for loop looks like the code in listing 3-5. Nice. Okay, so this for loops are implemented like they are in Python. These are like for each loops in C# and whatnot. I love this type of for loop. All right, for element in A, each element is in turn stored in this element variable. Yes, 10, 20, 30, 40, 50 until all elements inside array are done. Cargo run, and you get the same thing as the while loop. When we run this code, we'll see the same output as in listing 3-4. More importantly, we've now increased the safety of the code and eliminated the chance of bugs that might result from going beyond the end of the array or not going far enough and missing some items. Using the for loop, you wouldn't need to remember to change any other code if you change the number of values in the array, as you would with the method used in listing 3-4. So this is safer. That's probably why they opted for this. The safety and conciseness of for loops make them most commonly used loop constructs in Rust. Even in situations in which you want to run some code a certain number of times, as in the countdown example that used the while loop, most Rustaceans would use a for loop. Yeah, the way to do that would be to use a range provided by the standard library, which generates all numbers in sequence, starting from one number and ending before another number. Yeah. Same with Python there. Here's what the countdown would look like using a for loop and another method we've not yet talked about, rev, to reverse the range. For number in 1 to 4, reverse, in reverse, I guess. Print line number, lift off. Okay, sure. So that gives you this is a range or a tuple. What is it? 3, 2, 1, lift off. Nice. 1 to 4 in reverse. Oh, this is a range, I think, because 4 is not included. So starting value, but ending limit. It doesn't start at 4, it starts at 3. Interesting. Summary. We made it. This was a sizable chapter. Variables, scalar, compound, data types, functions, comments. Okay, sure. All right. Guess that's it for comments and control flow in Rust. I'll see you guys in the next video.